Hello? Uy, diri ko mag-live ba? Di, kaya akong nangita ra ba to si Tamtam diri? Unsa? Uh, tanawa akong ginahimo oh.
Ay, sa TV mo ginaano. So, kung i-direct yung gali sa imo.
Dili man ko ka-discuss kay kini gamiton dahil nako ni nga kwan kana ila makita sa kwan. Karon pa po nako ni na kwanan. Kay sa laptop man ang laptop man ako ana daw gamay nako may siguro tong dako. Ang mga taga-module kay daw wala man gapil.
Wala kita.
Oo, daw. Permiro, mapila ka kwan. Pagkakwan wala na. Ga-live naman ay ko ani. Istorya. May problema. Wala pa man sila nagkan. Nagbutang pa man ko sa Telegram. Ay, imong table. Imong table. So, okay na tayo. Nalibang ra ba tong miming? Di ba oh? Pero hapit na mauga, di man siya ba? Ambot nga nung gasulod yun na siya diri. Kanang open nga mga room nga na sudlan niya ba? Lusot siya. Nalimot ko ug unsa akong kuan ba nga karong junior high school na ko mga science. Either grade 9 or grade 10.
Ang saan sa karon?
Karon nga third man siguro na.
Third quarter?
Oo.
Ang sa next shift, sir?
Oo.
Si Ma'am Ivy po, kung si Ma'am...
Wala pa ko?
Wala pa, sir.
Ah.
Kuan pa ka. Mga January na po.
Sige. May kuan ko. So nakakuha ra si Tamtam?
Ano, sir?
Nakakuha ra siya? Isa. Ini silang kuan wala ni nag-share. Sila ni Sivan. Isa man nagawa pa na. Sa grade 12 na sila. Daghan na din sila.
Daghan sila.
Oo, silang channeling kakalan. Online sila. Wala na sila pila.
Mga stems, ano?
Si Agustin. Ang kuan niya kay si Carl na kuan. Na Ryan.
Oo.
Si Con, si Emilio, si Kaiser, si Abigail, si Joshua. Ano iban wala mo ba?
Pwede mo malista, sir, para
Oo,
matawagan.
akong gano'n na, si Jacinto. Si Jacinto, unang ko. Lisod na ba ang mga control of computation?
Tapos, wait.
Wala ba? Apil. Padalaan ako ng mga kuhan. Agustin. Saka Yurag. Say kuan ani man, grade kuan kini si Kirk or si Carl nga Yurag.
Si Kurt ang grade 12, sir.
Oh, okay. Si Shania, Kaiser, wala ko nag-apil. Nasir. Nanay duha. Good morning, Kaiser. We're about to start. Mga 2 to 3 minutes. Can you hear me clearly, Kaiser? Can you hear me? Sige. Mag-start na ta. We're going to start. Can you hear the sound of the grass cutter? Grass cutter o chainsaw ba? Sige, okay lang. Anyway, I'm going to fix the my slides. I don't have the more slides. I don't have the toolbar, taskbar. Okay, I have here. Okay, shall we start? May I offer a prayer first before we start? Gracious loving Father, as we start with our live stream class, we are praying that you will sustain us, O Lord, with your goodness, and you will guide us that may understand and learn together as we discuss these things. I pray for my students as they continue to learn from this discussion. I pray that you will be with them, to all of them, O Lord, that may finish the task they need to accomplish for this day. Thank you for hearing and answering our prayer. In Jesus' name we pray. Amen. Okay, good morning. And once again, I'd like to discuss the first law of thermodynamics. We are going to apply the law through these different problems. So this is, I'm going to review a little about the things that we have discussed yesterday about the Hess law. May I start? So, Hess law states that if a process can be expressed as the sum of two or more steps, the enthalpy change for the overall process is the sum of delta H values for each step. To use Hess law, two principles. Ga-on and off ang kwanda. Ga-on and off ang internet. Okay lang. Okay, may I continue? Anyway, you can review this because this is recorded. You can just review our discussion if we have some interruption. Now, here's the pathway. It is said that the road doesn't matter. The pathway is independent. So we have these reactants here, and we have the products. Now, we have also another pathway. So reactants, then we have the intermediate. This is another pathway. So it is said that the road doesn't matter since you will arrive to the same answer, the same product. Now, so I'll take note of that. It is because we are also applying the principle of conservation of mass. So no mass is being destroyed. Likewise, applying the conservation of energy, energy cannot be created nor destroyed. So everything, everything is conserved. Conserved. It may be released into the surrounding or it is utilized during the chemical process or chemical reaction. Now, rule delta H is the same the other way. Following the direct chemical reaction from reactants to products or passing through an intermediate route, then you have the same answer. Now here's the big idea. Now we have here the reactants. And this is the level of the energy being utilized during the chemical reaction. And the result, we have here the product. That means if we are using energy, the result of the delta H is being decreased, decreased. So here, the explanation for this is that during the chemical reaction, and here's the level now. During the chemical reaction, the energy is being utilized during the chemical reaction. And most of the energy is being released into the surrounding. Okay, released into the surrounding. There. That means this is what we call exothermic. Exothermic. Okay, so exothermic. Why exothermic? It is because the energy in the form of heat during the chemical reaction, most of this energy is released into the surrounding. That's why the result was we have lesser amount of energy in the product. So if we are going to use our formula, we have here product minus reactant. So P minus R, then you will have a negative result. Thermic, exothermic. Now, another example here, we have also this one, reactant, and then what happened? Going to another pathway, and the result is what? Here, this is another example. So we have product, and then we have here this is the reactant rather, and this is the product. Okay, so the result after the chemical reaction, the level of or the delta H is what? Increased. So this means that during the chemical reaction, energy from the surrounding is being utilized during the chemical reaction in such a way that the result of the delta H or the product is higher, greater than the reactants. So if we are going to use our formula, P minus R. Okay? So we have here greater. The result is positive. No? So when the result is positive, meaning the product has a greater delta H than that of the reactants. So this is now what we call endothermic. No? Endothermic. Okay, continue. We have here reactant. We have the result is negative 200 kilojoules. So this is exothermic. Exothermic reaction. Okay. We have here. Now, let's take up this thermochemical cycle. Thermochemical cycle is focused on using chemical reaction, especially elements and compounds. Now, so we're going to analyze how much energy is being utilized or being used during the chemical reaction. So here, the reactants, as we know, they are made up of elements, diba? Reactants. And we have also the products, usually, this is now the compound, because element plus another element would become compound, and usually the product. Now, during thermochemical cycle, we are going to break down the elements in order that we can understand how these elements can form into products. Now, so we need to break into elements, and then it will result to a product. For example, we have here, what is the delta H for the formation of ammonium chloride? Okay, so this NH3 is ammonium chloride. Then we have also another compound. We have hydrochloric acid. Take note that the state of compound or elements is always indicated. Now, if it is a gas, like ammonia is a gas, and we have also hydrochloric acid in the form of gas. Now, sometimes it's liquid, then you can, the notation here is letter L, enclosed with a parenthesis. Now, the product is now ammonium chloride, and it becomes a solid, solid. So, ammonia gas plus hydrochloric acid gas, it becomes ammonium chloride, which is also already a solid. Now, that's the product. Now, so what is the delta H for the formation of ammonium chloride? So it can be computed. Now we can solve the delta H, the enthalpy of this, as it forms the product. Here, so the breakdown, ammonia is made up of nitrogen and hydrogen. So we have N2. This is how we synthesize. Now we have N2 gas plus another hydrogen 2, which is still a gas, and then we have hydrogen. Since hydrogen here is a part of ammonia and also part of the hydrochloric acid. So that's why we have here this arrow, represents hydrogen rather, and we have chlorine here. So we break into the different elements. Let's continue. Now, if in the chemical equation, we have this NH3 and then plus hydrochloric acid. We need to balance the equation. No? Take note always nga unsay atong himuon. No? We are going to balance the equation. So, how can we do it? You look at here in the chemical equation. We have only one nitrogen. But here, as we break down the elements, we have two nitrogen here. So in order to balance, we need to what? We need to multiply. An integer is used to multiply with this here, now the reactant, in order that the result would be balanced. That means if how many nitrogen in the original chemical equation, it must be the same with the another chemical equation. No? So we have this one. So we are going to use 1/2. Since we have one nitrogen, no, in this equation, we multiply this nitrogen 2 into 1/2, then we will have now what? 1. Okay? So another, we have how many hydrogen here? We have 3 hydrogen in this equation, and then we have another hydrogen. That means we have 4 hydrogen. So we need to multiply this hydrogen into 2 to have this 4 hydrogen now in our product. Likewise with chlorine, because we have only 1 chlorine here in the hydrochloric acid, and we have 2 chlorine here, we are going to multiply this 2 to 1/2, and it becomes 1, no, in order to balance the equation. So this is now. So 1/2 times N2 plus 2 times 2, we break down water into hydrogen. Oh, no, not water. Hydrochloric acid into hydrogen and chlorine. And multiply again chlorine 2 to 1/2. So the product now is this. No? So we have now the product which, if you are going to to analyze the product and the reactants, is always balanced. So we have 1 nitrogen here, 1 nitrogen in the product, 4 hydrogen, no, elements in the reactants, and we have also 4 hydrogen in the product. You need to balance the equation, and the product is always equal or with the reactants. The reactants is always equal with the product. Now, applying the delta H on this equation. Here, if we have ammonia, when you break down ammonia, when you break down, you combine the elements, or you break down the elements, you are utilizing energy. That's why you have that delta H. We call that one as change in enthalpy. No? So you are using, energy is being used during the chemical reaction. So ammonia, during the breaking down of ammonia, so the delta H is negative 46 here. Negative 46. Breaking down hydrochloric acid, then the result is negative 92. That is the delta H. So you can assume that this is what? Exothermic, no, in nature. Because the result is negative. And then also in the formation of ammonium chloride, still negative 314. No? 314. Okay, may I continue? So here, there is now what we call enthalpy chains. We are going to compute. We have negative 46 for the ammonia plus negative, this one, 92 equals negative 138. Okay, 138. Okay, so there is change in enthalpy. No, change in enthalpy. Let's continue. Okay. Now, that negative 138, saan na to na siya? Okay, so we are going to, what's this one? We have here negative nitrogen 2 multiplied to 1/2 equals 1 n here. Okay. And then hydrogen is 4 plus 1/2. Okay, so here in this equation now, we are going to what? Negative 46 plus what? Negative 92 equals negative 138 plus this one, no, equals, the result is 314 for the product, which is ammonium chloride. And then, what are you going to do with that? This, our delta H now here is 138 minus 314, which is the delta H of ammonium chloride. So, the result of the delta H is 176 kilojoules. This is now our final answer. No, our final answer is, asagikan na siya, this 138, di ba? Which is negative, ato siyang gibalhin dito, diri, and then it becomes positive, minus what? The negative 314 for the ammonium chloride, which is the product, i-minus na to ang atong kuan. This is now the result, no? So the product, the result is negative. So this is exothermic. So we have P minus R. So what is our P? 314, 138, and we have this 176 kilojoules. Okay? Now, another example. This is still the same, I think. Di ba mo ni atong gidiscuss? We have now here. In its three, another way of analyzing the computation is through the use of summation atong i-total. Now, this is shortcut actually. So we have delta H equals summation of final. Kini this symbol. Delta H is equal to summation of delta H final, which is the product, minus summation of delta H final reactants. So we have here delta H is equal to minus 314 minus times negative 46 plus negative 92. So we have this is another pathway where we can have still the same result, no, the same answer, which is 176 kilojoules per mole. or kilojoules per mole. Okay? Now, direta sa computation karon. Now, so I think we need to focus on this because we cannot understand this easily without focusing on our computation. Now, so this is one way how to discuss it simply. Okay? So we are going to use letters. So we have here, for example, first equation, A plus B equals C. Ako na nang i-discuss. No? A plus B equals C. And the delta H here is 100 joules. Second equation, or C plus D equals E. And how much? The delta H is doubled. Gidouble na to. Na-double siya. And the result is C plus D equals E. Okay? So, padayon ta. Now, what happened if we will create another chemical reaction? Number 3. So, first, we are going to eliminate. No? We are going to eliminate the same terms. No? Kung sa algebra pa, the same similar terms. We are going to cancel. We are going to cancel out similar terms. So here, what letter you can find from chemical reaction 1 and chemical reaction 2. So we have here C. It is because A plus B equals C, C plus D equals E. So this letter C is found on chemical reaction 1 and chemical reaction 2. So we will not include that anymore because we canceled out already. No? So in the third equation, we will not use anymore C. Okay? So we have now here A plus B plus D equals E. Okay? Now what happened? We add the first equation, chemical reaction, and then second, in such a way, we have now the delta H, the sum, or the total of the delta H in what? In chemical reaction 3. That's what happened if we are going to multiply these letters with an integer. We are applying the Hess law. So take note of the discussion a while ago na if you multiply it with the integer, the delta H should be multiplied also with the same integer. Okay, here. A plus B equals C, 100 joules. Now, second reaction, 2A plus 2B equals 2C. So, naanay 2. So, what happened? Multiply na to ang 100 joules to 2. That's why we have now 100 times 2 equals 200 joules. Okay? Now, in the third equation, we are going this to 1/2. So, 1/2 A plus 1/2 B equals 1/2 C. So what happened to the delta H? It reduces from 100 joules, it becomes 50 joules. No, 50 joules. So I think this is much clearer explanation. Mas sayon-sayon nato siya sabton because we are just using letters. May I continue? Now, what happened here? If we are going to reverse, kanina, di ba, naanagyapon sa atong applying the Hess law. If you are going to reverse the equation, you are going to reverse also this sign of the delta H. So from here, we have now look at chemical equation 1 here. So A plus B equals C, 100 joules. Now, we are going to reverse the equation. So, instead of A plus B equals C, we will have C is equal to A plus B. So, in the type of, what is this one? I forgot the term. Chemical equation, types of chemical equation. Yes, this is now what we call decomposition. That means product first and then the reactants. So, gi-decompose na to. Like for example, product is water. And water is the product of hydrogen and oxygen. So, water, so H2O is equal to H2 plus O. Mo ning ang gihimo nato karon. We reverse. Now, we reverse the equation. So, C is equal to A plus B, then the delta sign now here is negative, no? Negative 100 joules. Okay, so this is the reverse. We are applying the law, like we use the different integers, and then we reverse the equation and how it affects the delta H, the enthalpy, no? Enthalpy. Okay? Let's move. So we have now here. How about this one? Another equation. 2A plus 2B equals 2C. Okay. And the delta H is 300 joules. Sa atong gikuan, puros 2 ha. 2A plus 2B equals 2C. And 300 joules. Next equation. E is equals to E equals C plus D. This one. Doon sa nato ni siya. Gipadayon lang sa. And then for number 3, we have here. A plus B plus D equals E. So we eliminate first C. Kini. This one. No? Atong gi-eliminate. So that's why we have here E equals C plus D. Okay. So, pag abot sa number 3 equation, in number 3 equation, because we eliminate C, we have now A plus B plus D is equal to A. And what is now the delta H? This is the Now, this is now the problem. Okay? So here, this is the computation. A plus B equals C. Then, eliminate na tong C. Cross out na to. 150 joules. C plus D equals E is 400. Why is it that it becomes 400, positive 400? Okay, 400 positive. You look at the equation number 2. We reverse. E equals C plus D. And on this equation now, we reverse the equation. So, C plus D equals E. So, this is a combination, no, the type, no, of chemical reaction. This is combination. We combine C plus D, the result is E. Now, the negative sign of the delta H now becomes positive. So, we have positive 400. So, we add, in the third equation, we have A plus B plus D equals E. So, we eliminate C. Wala na yung C, di ba? Okay. So, we have A plus B plus D equals E. So, that means we are going to add the AB delta H plus CD delta H, and then we have this 550 joules, now which is our delta H. Kapit na kita. Kini. How about if we are going to multiply to 1/2? Kini. So the same thing. This 300 joules, after multiplying it with 1/2, so 300 times 0.5, mahimo po siyang 150. 150 po siya. C plus D equals E, 400 joules, and this is now the result. So asa gikan ang 150 because we multiplied it to this integer 0.5 or 1/2. Okay, hapit na. Diri na ta karon. Kay ato ning gi-compute, no? Ato ning i-compute kini siya. So this is now, I have 2 problems lang I think, no, for you. So pag ma-solve na to ni mahuman na dayon ta. Okay. So we have the first equation here, 1. We have 2. And this is more challenging because we are now applying the First Law. Unya, na siya, kining chemical equation will not be using letters in the alphabet anymore, but unsa na ni siya, mga elements and compounds. So first, the equation is this: 2 ammonia, no, is equal to nitrogen 2 and 3 hydrogen 2. The delta H is positive 92. So positive 92. Okay, take note. Kay gabali-bali ra man gud ni siya ang equation, no, during the chemical reaction. So we have now, for number 2, 2 molecules of water. Kini mga coefficient, mga molecules ni siya actually. This one, the subscripts represent the atoms. No? So nabalaan naman na ninyo. That's why we don't need to discuss that further. No? Kini, unsa ni siya? Coefficient. And it represents the atoms. So this is how to discuss it or to explain it. 2 molecules of ammonia is equals 2 atoms of nitrogen and 3 this one 6 na ni siya. It could not be molecule because this is diatomic, no, gitawag nato diatomic hydrogen. Okay, equals 92 delta H. For the second equation, here, 2 molecules of water, and then we have 2 H2 and 1 H2. 1 lang ni siya. Number 3 equation. By the way, these equation are given, dili na siya kay kuan. Sila kini given na ni siya daan, including this number 4, kini ang result niya. So dili ka mating-alang anong naingani na pud siya, and then what happened to the next equation? No, these are given. Oy, balik. Given na siya, given in the problem. So lies later on. Now, based on this result here. So number 3, nitrogen 2 plus oxygen 2. Then the result, the product is 2 nitrogen oxide, which the delta H is negative 180. So the result of this, giunsa nila paggamit ani ila na nang gipang eliminate diha ang kanila hangtod nga the result, the final, because like for example kini oxygen 2, we have oxygen 2 crush out, cancel, no, we are going to cancel out. So the result is 4 ammonia plus 5 oxygen 2. The product is 4 nitrogen oxide plus 6 water, molecules of water. So ato ni siyang i-itemize atong gikuan tagsa-tagsa, no? How did we come up with the answer? Nganong naing-ani ni siya? So first we will recreate the we will anyway. So the result is 1,892. 1,892. Okay, there. So that is our delta H. No, delta H. So then, okay. Again, we have still here 5 O2. Kini. So we have this 5 O2 here. We are going to multiply it to 1/2. No, so we have here oxygen 2 plus 3. Okay. So asa naman ang atong 5? Kini. We don't have this one anymore. Kini. So 5, asa gikan? This oxygen here, 3 plus 2 equals 5. So that's why we have now this one. Okay? So 5, this one, oxygen here. How many oxygen? So 3 oxygen plus 2 oxygen here equals 5. Okay, there you are. And also here. Tama na. Tama na. Last problem. Last problem. Okay? So we have this pare-pareha ra gyapon og kan ammonia ang gamit nila nga problem. Okay? Okay. So we have but we have different equation, I think. The same. N2O2. NH4. Okay? But we have okay. I don't have the we will have, I think, okay magsulat kog another problem. How will I add? Problem man akong gibutang dire na-solve naman nato ni. So we will have another problem here. Dugay-dugay ni pagkanda. Okay, here. Never mind this kay the same problem akong nabutang. So no more. This one. Last na ta. Okay, 1. First equation. 2H2O. Hinay ra ako magsukan. Okay, 2H2O. Then the product is 2H2 plus O2, oxygen 2. Ganyan siya. And then, second equation, here, carbon dioxide, CO2, the product, decomposition, carbon plus oxygen 2. So we have now there. Third. Third. 2 C2 and hydrogen 2 here. We have 2 equals, we have plus oxygen 2 equals 5 oxygen 2. There. Then the product is 4 carbon dioxide, 4 carbon dioxide. So 4 carbon dioxide. This is our basis, ha? Oy, sorry. Our basis now here. So we have C2, it's 2, plus 2C equals 2C there. These are given, ha? Don't worry with this. Kaya given na sila. Given. Then 2. Okay. So this is now the equation. After forming this 1, 2, 3, we have this product here. So you look at, no, here. Say sunod na to. We are going to focus asa man ang kwan, dili kay ta mag-focus sa water. We are going to cancel out. Again, we are going to cancel out now here. We have the equation 1, 2, 3. You look at the same, unsa siya, the same or similar terms. And then ato siyang dili ta mo focus ana. Like water, we have water in 1 here. Water, again circle na kung water. We have also water here. Diba? So again circle na kung water dire. We have also unsa pa? Oxygen. Na oxygen dire. We have oxygen here. And we have oxygen here. Katong atong fokusan karon, how about H2? We have H2 here. And we have dili na siya H2. Ay sorry, wala H2 di ay. Di ba? Wala H2. Sorry. So plus C2 plus 2H2. Uy, sorry. This is not hydrogen. This one. This is 2C. Again ha. Asa man ko gikan ani. So the result is 2C. Anong naman ko yung water? 2C plus CH2 plus 2C. There. Okay ha, we have 2C. So here we have 2H then oxygen. Tama ni siya. Oxygen. How about hydrogen? Wala na. We don't have hydrogen. Kini ha. You cross out this one. Dili na siya. Pwede. Okay. So we have 2H2 here. Good sa mga erase, no? Sa pag-erase, be. We will have an eraser. Okay, atong erison. Okay, good. Pwede raman dahil ma-erase. So, we don't have H2 on the other equation from equation 2 and 3. So that's why we will retain this one. So, I thought manggod kini H2, but this is C2, H2. Okay. So we have now here our product. So after we encircle these similar terms here, we have carbon dioxide here. Carbon dioxide here. Kini carbon dioxide. And we have also carbon dioxide here. Okay? So this makes our equation simple because those terms, those similar terms are already what? Eliminated. So we don't focus it, although they are not totally eliminated, but we don't focus anymore our computation on those compounds that are already encircled. Okay? So per miro. Now, first is, what are you going to do? Because this is now, we have 2 H2 here. And we have 1 H2 only here. You look at this, I will change the color of my cursor. Akong ilisan, aron makakwanta. Color, ink color. We have here, blue. Okay, we'll have blue. Now, you look at this. We have 2 H2, but we have 1 H2 here. So, how will we balance this one? By way of multiplying it to 1/2. That one. Atika muna. We have the delta H. I have not indicated that delta H. So the delta H here is 572. 572. For the second equation is plus. Second equation is plus 394. 394. Okay, there. And for the number 3, here is negative 26, negative 2600, 100. So 26, this is negative, this is negative 2600. Okay, let's go back. Now, as you notice, in our first equation, we have H2, 2 H2, whereas in the final answer, we have only 1. So, we are going to multiply this to 1/2. So, pag multiply na to sa 1/2, what happened? This 2 H2 here would become H2. Kini na siya. So, we are going to multiply this also to 1/2. So, that means this 5, what happened to this? So, this 572 would become 286. Okay, o 286 na lang na siya. 286. Positive, Okay. Now, anong place nga atong kuan? So, is direta sa kuan, water. Okay? So, we don't focus this too much, ato ni siyang i-reverse. Pila ang water nato diri? Wala. Diba? So, we focus here, kining H2. So, that's why, gikuan na to. We will have this. May I utilize this space from this? Diri. So, first is we have H2O. Although we don't mind too much water, but still it's part of the equation. So, ato na siyang ibalik diha. Okay, there. So, H2O, pila man siya? H2, Uy, ano sa ba ni? May I erase this? Ako sang erase kaya marag dili klaro. Erase. Dire. Then, may I have this? It's water man siya. So, water is H2 plus. Water is 2 plus oxygen 2. So now here, since we multiply, you look at here, this is 2. And in our answer, we have only 1 here, 1. 1 lang ni siya, 1. Though it's not correct to place 1 here, it is understood. But just for the sake of explanation, no, ato ni siyang butangan og 1. Okay, I will erase that para Okay. So, what happened now? We multiply this with 1/2 So this, kini. So it becomes 1. Okay? So for oxygen, no need. Kaya wala naman siya dre, eliminate naman nato siya. Okay? So that's why we have this answer here. It's 2. We multiply this 2h here with 1/2. So it becomes 1. Kinigapon, this oxygen here, which is 2, multiplied it with what? With 1. Okay? 1/2. Next is number 2. Number 1 na siya. 1. Okay, number 2. You look at this. Kini. This number 2. This one. So we have 2 carbon dioxide. We have 2 carbon dioxide here. There. And then we are going to break down the element. So we have 2C plus 2O2. 2 oxygen, 2. How did we do it? No, so we multiply to 2. Kini. Because we have 2 carbon here. And we have only 1 carbon here. Okay? I'm referring to number 2 equation. We have only 1 carbon here. Oh, this one is C. And in our answer, we have 2 carbons. So we are going to multiply this with 2. Kini. Second equation. Multiply with 2 times 2. That is the integer. So everything, you are going to multiply that. Sige ha. So that's why you look at carbon dioxide, 1 only, times 2. So nahimo ng 2 carbon here. How about the hydrogen? No, this one. We have 2 carbon dioxide now here. Kanina, 1 only. We have 2 carbon also from here. Then, kanina, unsa man siya? Naimong 2 dire. So, to balance it, we multiplied the equation with 2. So, 2 times oxygen. So, we have 2 oxygen. Multiply this C with 2, we have 2 carbon. I hope you are, okay, again, this equation in number 2, we're going to multiply it with 2. 2 oxygen, so we have now here. Multiply this 2, we have 2 carbon here. Multiply this carbon dioxide with 2, so we have 2 carbon dioxide here. Diba? So we are going to balance, kung balance na ba? 2 carbon, 2 carbon. Oxygen 4, oxygen 4. So balance. Let's go to number 3 equation. Last equation. So 2C H2, no? I-eliminate nato na siya. So our focus now is C2 H2. This one, C2 H2. So how did we do it? No, so C2 H2. Diba? So we have here, kuan naman na siya. Kini ato ning kuan. So we have C2 H2. Here, we will write it here. C2 H2. Wala na may laing. Okay. So C2 H2 still the same, plus 5. Asa man gikan ning 5 nato dire? 5 over 2. Oxygen 2. Oxygen 2. Okay? So, equals, I have limited space. Dire pwede na nako dire ha, dire ta. I'm going to bring it here. So the answer for this is 2 carbon will make 2 carbon dioxide, 2 carbon dioxide plus H2O. There. So this one now. So asa man tagikan ani. So we look at our answer here. So we have now this 2C2. Oh, so giunsa nato ni siya ato gi kuan no gi multiply nato sa 1/2 kini. Okay? It is because, ganong i-multiply nato sa 1/2, this one, third equation. Why did we multiply it with 1/2? It is because we have only C2H2 here, and in the third, we have here 2H. We have 2C2H2. So multiply this with 2, kini times 2. So the answer would be C2H2 again. So we have 2C2H2, but in our answer here, we have only 1. So multiply that to 1/2 here. Can multiply that to 1/2 there, and the answer is C2H2. Multiply this to 1/2, 5/2, kini siya. So what happened to that? Nahimo na lang siyang sa 5/2. So the result of this is na-eliminate na ni siya. That's why we have now here, no, the answer is 2C. Where is the 2C? Okay. So 2C, where is that carbon? We have here carbon. That carbon is 2C. C2, and then we have H2 here. Okay. And for that oxygen, we have this 3 oxygen. No? So, gikuha na to. Gi-over 2, 5/2. So, atong i-round off na siya. So, we have 3 oxygen here. Okay? So, this is how we do it. Although, I don't think so if it is clear to you. Pero, ing-ani pag-compute, no? If you just pay attention deeply on that, maka-answer ta. Okay, so let's go to the delta H. Last na ni. So in the delta H now here, as we analyzed, we have 286, kini, this one, 286 plus 788, kaya gin-multiply nato sa 2, no? We multiplied it to 2, ang 572, no? So, plus, nahimong, multiply this to 2, 86. Multiply this to 2 again. So, we this one, negative 1300. Delta H here. Delta H equivalent is 200, negative 226. So, now our delta H. Okay? So I think we need more explanation of this because I think dali-dali ni siya masabtan. No? This is one of very challenging problems, no, in chemistry. And I tell you, when you enroll in medical courses, especially mga pharmacists, mga engineering, chemical engineering, you really need, no, knowledge on this. Kini siya nga mga topics, no? Thermodynamics. You will not become engineers if you will not master this topic. Okay? So I think it's enough for this morning. Muna atong discussion. No? So thank you for joining us in our live stream. Thank you very much, everybody. Although sometimes the internet is interrupting us, but at least we have finished our discussion. So you can also view this one, and also you can read more, read more about thermodynamics, especially applying the Hess law. Okay? So thank you, everybody, for joining us. Humana. Maglisod. Maglisod ko. Sulat bitaw. Kano, hinay kay ko magsulat. Naato yung program bukid ng tanong.
Oo, sir na, sir.
Ay, bro, kahit ko di ay.
Palit ka sa Shopee.
Magpalit sa'yo ba?
Sabi kayo basta mouse. Tapos sir,
Naato dito?
Oo.
Hindi rin kumana. Ay, kakakong gamito. Sige. Katawanan. Karon pa pagod ko kahuna-hunaan yun ako, mas maayo siguro itong taman ako, mas screen.
Oo.
Kaya dito sa balay, kiniyo akong ban, sa akong ginahimo dito sa balay, kapalayo ko, dito na ako gibutang sila, diri ko ano. Si Potpot na mo, wala na.
Kaso naman siya, sir.
Ayan, matay na to Grabe ka sutil kayo, Eric.
Lagan.
Lagan nga sutil yun. Kaya kulungon doon ako ni Mrs. dito. Go-wild na siya, pangguba ng mga jealousy.
Kuyo.
Wala kayo siya magdugay. Kay batlungon mo kayo.
Ipamilang sa ginikanan.
Nagpawilding na di ako ato upan. Yung mga grills na ko.
Para sa kulungan.
Para sa iya. Nagagasto ko mga 3,000.
Uy, kung sabi ng...
Kanya, pag nahuman na yun siya, naanat sa balay, wala mo na siya uli, ilang adlaw sa ipupagita, wag kita siya. Pag uli niya, yung dry-dry, yung uli si Putput, pero hindi, daan ako na yung balik. Iko ka na, ang bangkaon, wala ka bantayan. Pagbalik na mo, wala na siya kabalik. Ako na nang nawala na po sila.